Hello and welcome to a new tutorial on our channel. In today's video, we want to show you how to build an application with Peakboard that allows you to read and set values from a Beckhoff control where a program is running in TwinCAT. In our example, we will connect a plant consisting of a pure water tank that can be filled via a pump, heats the water, and then releases it through a drain valve. First, we create a Beckhoff TwinCAT data source. We give it a name, set the reload interval, and then enter the AMS net ID. Since Peakboard uses the Beckhoff ADS protocol to load data, we can directly access the Beckhoff control and read and write values. If you need a router to access the control, you can also select this option and then enter both the AMS net ID and the IPv4 address. Next, we can already load the programs on the control and select the program we want to work with. We select the main program, and we're immediately shown all available variables. Here we can deselect the tags we do not need and then load the data. With that, we are already done creating our Beckhoff data source. Next, we create a time data source to display the current time and use it in the script. Then we can start designing the application. Here we start by selecting a different color scheme and making minor adjustments. Then we divide the visualization into different areas using rectangles. The first rectangle contains the description of the dashboard as well as the time and date. Here we adjust the formats accordingly to display them as desired. The second rectangle will include a representation of the plant SCADA style, as well as a history of the two values, water level and water temperature. Let's start by creating the elements. First, we create the pump that pumps the water into the tank. Next, we create a rectangle that represents the pure water tank and another rectangle that represents the drain valve. After positioning the elements, we create a conditional formatting that colors both the pump and the drain valve green when they are switched on or open, and red when they are switched off or closed. For this, we choose green as the initial color, and then we only have to create a condition that changes the color to red. With conditional formatting, it is advisable to set a condition as the initial state, but it must be considered that in our example, green would be the initial state in the event of a loss of connection to the control, which could lead to problems. For the outlet valve, we can then display a text field that shows the current degree of opening in %. Then we create bar charts for the current water level and water temperature in the pure tank. We link these valves from the control system and adjust the maximum valve. We also create a scale for the two bar charts. To now record and visualize the history of these valves, we create a local list which we call tank history. We add a column with the time, a column with the temperature, and a column with the water level. We fill this list via a refresh script on the TwinCAT data source that is always executed when the data source is updated. To also follow lateral trends of the valves, we select the option that the script should only be executed when the valves change. Then we create a building block that adds the valves to the list and then link the corresponding values. For the time, we set a desired format. To display the valves, we create a chart control in which we set up two line charts that each represent the water level and the water temperature in the pure water tank. Besides the colors of the two line charts, we also adjust the scale and the legend, and then are done displaying the values. Next, we want to create the interactivity that allows us to turn the pump on and off to open the drain valve by percentage. For the pump, we create a simple button on which we create a script that should write towards the Beckhoff TwinCAT data source. For this, we have to define the program and the variable that should be written. For the valve, we create a local variable that we set to the opposite valve of the pump in a simple if-else condition to turn it on or off. Setting the outlet valve is a bit more challenging. Here, we first have to create a local variable into which we write the new value. Then we have to link this with a slider control and name it as well as display the value. Next, we create a script that initially writes the set value from the control into the variable. From now on, the value of the variable always sets the value on the control, but the script only needs to be executed once. Next, we create a value changed event on the slider, in which we write the new value for the valve to the control, like turning the pump on and off. Finally, we create an icon that is supposed to indicate whether the pier tank is currently heating. For this, we also create conditional formatting again, and then we're done with the visualization. In the preview, we can see how the pump can be turned on and off, the pure water tank is heated accordingly, and how the water level changes when the valve is opened. Thanks for watching. We hope you enjoyed the video. Please leave a thumbs up and subscribe to the channel if you don't want to miss any videos. If you have questions about the Beckhoff TwinCAT data source or suggestions on what topic we should cover in our next video, please write us in the comments. Thanks.